It's just an aluminum rod. Come up here for a second. Or I'll come to you. It's even easier. So we put a little bit of rosin on it to make it sticky, and if you drag your finger across it, and you see the black part where it's all sticky, it's going to make your thumb a little black. So just squeeze with gentle pressure and try pulling along it. And you want to hold it right in the middle. It started.
Yeah.
Okay. Here, in fact, I can hold it for you.
Okay.
You just. Would you like to try? It's going to go all the way. Somehow it comes easier at the end there. Now you as a musician will appreciate sort of just the fun ways that you can make noise with different things.
That is pretty crazy. What do you do?
Just squeeze it and pull it like all the way down. For some reason it tends to work best at the end. Hurts a little bit?
I don't know. It feels awkward.
So there's a little bit of rosin on there to make it sticky, which allows us to initiate our vibrations.
That's pretty cool.
And if I feel really slick about myself, I'll try it there. Oh, not quite the right spot. And I can get a much higher pitch.
Oh, nice.
And I'm going to rebalance it here, because this one's the much easier one to do. So there's certain places, just like when you play a string, there's certain places that it stays and it doesn't move. Those are called nodes. And if I hold it at different nodes, I can force different notes. But it only works in certain places.
Mm.
Okay, so guys, you can Now this one's a little bit easier to work with. Thank you.
Nice.
Okay, come on, join us up front. We have a small group, and we're going to do some intimate science experiments.
Did you really just say everybody gets their chance. I just need a small different stuff comes out. Something that'll grip better than the side cutters. Just don't squeeze it too hard, or she knows what it is. Dude. There you go. Yeah. It burns your fingers. It does a little bit. Well, you just keep on going. Alright, shall we go on?
Yes.
We're going to do some more of our
So now, can you perform like a little concert between the two of you?
Yeah, we just need all the notes.
Oh, yeah. That's where the turkey baster comes in. Would you care to? Okay, ladies and gentlemen.
So this was one way to make sound. And what we're doing with sound is we're just making air vibrate. But Chris here has got another way to do it.
How many of you guys have one of these at home? In the kitchen? And when you're not using it for food,
Well, I'm not sure.
when your parents aren't around, you can grab it out of the kitchen and throw it in the water. It's the same as blowing over a bottle, but here I can change the water level when I squeeze it, so I can change the note. And if the water level is really high,
Guys, come on into the shade so
if
you
the
don't get
water level is
sunburned.
low,
Yeah, that's all this is.
yeah, I think
Chris is the master of that. We used to use a Coke bottle, but a Coke bottle isn't so good because you can't squeeze it. But you can change the level of the water. How can you change the level of the water inside a Coke bottle?
Pour it out.
You can pour it out. Although we're from Arizona, so
we don't ever put water on the ground. I just did mine. Probably the best place is to
And I used to have the most terrible time trying to get the notes to go up again by spinning up back into the bottle. That's why we started using a turkey baster as well.
Fish tacos are good.
And then when you're done playing tunes on the turkey baster, in Arizona we always we reuse and recycle water.
So this little turkey baster, after becoming a musical instrument, then is used for hygiene. So we take showers. We gotta shake it around a little bit.
I'm gonna get a whole turkey baster full of water on my head in a moment.
Hey, wait! It didn't all come out.
No.
What's going on there?
Weird. Just little bits are dripping.
Hey, I didn't get my whole shower.
On the other hand, so if we turn that one over and we just let it go, did all the water come out? But if I turn this one over and let it go, will all the water come out? What do you think? So we should try it, right?
Maybe that's more of a shower than I want.
So we try the one and it just sort of stops. On the other hand, if I use this one, it sort of all pours out. But they both have air in the top, right? If we look at that one. And yet for some reason that one it doesn't come out, but this one it does. So why is that? What's different about these two?
The hole.
The size of the hole, right? So did you guys know that water is sticky? Have you ever heard of water being sticky?
No.
If you see 2 drops of water come really close together, what happens? And if they touch, they snap together right into one big bubble or one big drop. And that's because water wants to pull together. It's this thing called surface tension. So in this one, because there's such a tiny hole, the surface tension is pulling so tight that the air can't get up. And if the air can't get up, the water can't get down. On the Coke bottle, it could get through. And on this one, there's no way I could turn this one upside down, right? Without pouring water all over everything.
Did we change to do this over his head?
I'm going to put this one, I'm going to turn this one upside down over my own head.
Uh-oh. I'm getting out of here.
Now, I'm going to use this. Oh! Maybe I'll use a little
gravity. Oh, gravity.
That was gravity. That's right.
Everyone saw it. That was
It's always good to check that gravity is still working because, you know
And
what?
it's also proof that I'm using real water. So anyway, now notice if I tilt the glass, the water stays parallel to the ground, right? It always stays flat. But watch, something's going to be a little bit different if I swing it around on this thing. So you think, like, all I have to do is tilt it just that far and it starts pouring out. So I'm going to definitely tilt it that far.
Centrifugal.
Whoa! And something is not, like, is gravity not working? They should be falling out, right? Now,
Someone didn't pay the gravity bill.
so will you check, was there anything sort of sticky about this? Is this real water?
Because you're doing it fast enough.
It's because I'm doing it fast enough. And in fact, you feel a bit of a tug, right? You want to run back there and do that?
Oh, I have one of these. Are you going to do a gravity experiment?
Wait,
Well,
don't
he's
look
going to
at me
set up.
just yet.
Okay.
So, now, would you mind doing it for us? You don't have to use the water. You can just use a tennis ball.
Okay.
All right? That way, if it all goes crazy, we won't get super
You notice
wet.
the tennis ball isn't stuck in there either. And we're giving you this special cup. It's made out of plastic. You can see we've used it a bunch of times before. But every time it falls, it doesn't.
Oh, yes, just a little bit faster. And why don't you swing it back and forth a couple times before you go upside down. All right, now go ahead and swing it all the way upside down, kind of fast. Perfect! One more time.
Yay!
All right, now I have a question for you. Did you feel a tug when it was upside down?
Yeah.
Yeah. So that tug that you're feeling, was that caused by gravity? Because gravity's pulling it down, right? If I let this go, would I feel a tug?
No.
No, but you still felt a tug.
Yeah.
And that's a study of a force. And it's a study of an acceleration. And those things are what we study when we study physics. So when you talk about physics, you're talking about the world around you. Now, if you guys would all turn around and face Devin over there, he's going to show you the first physics experiment ever done. Well, maybe the second ever done. So it started a long time ago with a guy named Aristotle. And he decided he wanted to see what would fall faster, a rock or a feather. So will you guys head over there real quick?
Come on over. I don't want my voice getting tired. I've got a lot of hooting and hollering that I have to do later today.
How do you guys come back and forth a lot?
That's right. we were hooting and hollering for your playing too.
So, we were talking about gravity, and gravity's been around for how long?
Ever.
A long time. So, people have had a long time to try to figure out what's going on with gravity. What's the deal? And a while ago, there was someone named Aristotle.
Hey, where you going?
He was back in Greece. And he got two objects, and he said, if I drop them, which one's going to hit the ground first? Now, he didn't have a basketball and a racquetball. He had a rock and a feather. And we could probably go pluck one from the chicken and go find a rock somewhere else. But we're going to do this right now because somebody else named Galileo decided, well, I want to make these two objects a little bit more like each other. So I'm going to get two things, one just being bigger, one being smaller than the other. And he said, hey, student of mine, you see that really, really tall thing over there, the Leaning Tower of...
Pizza.
Pizza, yes.
Pizza.
He said, student, I want you to carry these two cannonballs up to the top and drop them, and then pick them up again and do it again. And we're going to figure out which one hits the ground first. So we're repeating that. Who thinks that this ball is going to hit the ground first?
What does it weigh?
Oh, it's heavier.
It's heavier than that one?
Yeah.
A couple of pounds. WNBA standard.
Well, we'll have to test it. So make your predictions, everyone.
Blue.
Here we go.
Blue.
All right, and they're off to the races.
Same.
Good rebound.
They seem to be same.
It was pretty close, huh? Should we try it again? Yeah. All right.
Same.
Oh,
Basketball, I think.
it was the basketball.
Pretty same.
Now, you know what I'm starting to think is maybe I can't drop them at the perfect exact same time. So maybe I should go swap out my brain for an electronic one and then everything will work. Or not. Maybe we'll just have to keep repeating it.
Maybe try them from
Or how about you put it
upside
on
down first, and then...
ladder you have, and then like roll it up.
Well, that's a great idea. Now, can you do this at home? Can you make this experiment better than I'm doing it?
Yeah.
Yeah. So, well, I'll move on to one other thing. Now, when I drop these, how high do they come back up? Not all the way, right?
Like halfway.
Like halfway. And sometimes it depends on the thing that you drop, right? So, I'm going to show you a way that if you drop them, one of them actually goes higher than the other. And I promise this isn't magic, even though we're hanging out at this beautiful farm that almost seems like a fantasy. All right, you ready? And I might need some of the youngsters to chase this down. Here we go. Whoa! So the blue ball went way into the air, but who saw what happened to the basketball? It didn't go very high, right?
Yeah.
Now, in science, we always have to change our experiment. We have to make something a little bit different. So, I'm going to add another ball in here, and then I'm going to drop them. Make your prediction. What do you think is going to happen to that blue ball?
It's gonna bounce super high.
All right, here we go. Whoa! Yeah.
That looks like fun.
Hey,
Why don't you give that?
Oh, yeah. All right. They've all came back.
Thank you. I don't get that.
So the blue one went way up into the air because we added this ball. Now, I hope that we're doing this segment of the show because I'm going into it anyways. Does anything strike you as funny about this ball? Like, is there something on this ball that you can tell me?
It's plastic.
It's plastic? It's rubber, sort of like plastic. Well, but there's something that's on all of the ones that we're holding.
Air?
Princesses! Yes! And this is the time in the show where we remind everybody that for a long time science was done by men and old men with no hair. Now, that's because we were a little backwards. And now, we just want to remind everybody that boys and girls especially, need to do science because they're just as good and sometimes better than boys.
Frequently better. What would you say, James? Okay, ladies and gentlemen, back to the main stage. That's right. Ladies and gentlemen, girls, boys, and everybody.
No, it's backwards.
Just trying to figure out this whole gravity thing.
Well, and as soon as you figure out gravity, then you can start on anti-gravity. If gravity makes things fall, anti-gravity is anything that holds things up. Oh wow, that's pretty impressive. Like the mysterious force that seals use to balance a ball on their nose.
Now, does anyone here think they can balance a ball on their nose? Will you come up?
Yeah, give it a try,
I'd like you
bro.
to try briefly.
I want to.
Will you try with this one? All right. Is that challenging?
Practice.
So hold on, we're gonna keep you up here for just a minute.
Practice.
Try with the bigger one. See if it's easier with the bigger one. It might be a little bit easier. And if it's easier with that one, oh. Maybe we should go the other way. Let's try a small one.
Okay, there you go.
Try the racquetball. So which do you think we got it?
That one.
Ah, that one was the easiest?
That's so odd.
And that one was the hardest? But this one was somewhere in the middle, right?
Yeah.
Now, so if it fell sort of that way, which way would you have to put your nose to make it not fall down?
This way.
That way, sort of underneath it again, right?
Yeah.
Now, what would happen if I told you I had a magical machine that when it started to fall, say, to my left and to their right, that it would push it back? Do you think that would make this easier?
Go that way.
So it would always push it back from whichever way it went?
Yeah.
Yeah? Would you like to see my magic machine? Here it is, right here. Alright, now, I need everyone to be really, really quiet so you can hear the leaf blower. Alright, will you hold this?
Leaf blower? I thought it was a magical machine.
It is. It's a magical leaf blower. I'm going to ask you to hold the ball above here and then come down to about here, and when it feels like it's weightless, let it go. Alright?
Check. Check. Maybe a little bit less guitar.
We can try it.
Check. A little more vocal, 1 and 2.
Guys, will you come up here? Come a little closer, because now they're doing sound check. Nobody can hear our leaf
Will you hold
blower.
this one for a minute? Are you ready? You're going to do the same thing, okay?
Oh, you push it a little bit?
Alright, will you grab it? Thank you!
Wow.
Okay, and now...
Good job.
We're going to select another volunteer.
Yes, sir.
And because whenever you're doing experiments...
We want to vary different parameters. So, for example, both these balls were smooth.
Very good.
And this one is much smaller. It might get shot up way up into the trees.
I forgot your name. Bo.
So notice,
Okay.
what was weird about the tennis ball?
We're here to tell Bo, don't be discouraged. Well,
It's not smooth?
Yeah.
it's a little different. Absolutely. We're going to let Bo try it one more time. But now our hypothesis is that maybe what's on the surface makes a little difference. And you might notice that one of the differences. How did I come? I chose Bo. Well, Bo has plenty of fuzz on the outside, just like the tennis ball that I gave him. I have a little fuzz on the outside, just like the racquetball and the other ones we've been trying. And I don't know if you've ever wondered how come airplanes don't have green fuzz on the outside. But you can probably. Well, now you have a hypothesis.
But he has a bigger brain. Can you notice the difference in the brain size?
That device works with fast-moving air. Sometimes we want to study slow-moving air. So we built this device.
That's right,
That's
because
a fancy device.
in fact we sometimes talk about safety. You know, you don't want to point this at somebody's.
Maybe I need to go downwind. And what does it make?
Smoke signals.
Look at those. They're like perfect Cheerios. And I'm going to go over here so you guys can have it coming straight at you. You can see them coming at you. Are you ready? Do you feel that pulse of air?
What's it? What is it? What's the smoke? What's smoking in? What's smoking? Oh, that's it. That's connected.
Okay, a little more.
Now, this isn't like cigarette smoke. It's actually theater fog, so it's not toxic or anything. But it does smell kind of funny. You ready? And notice what happens when you get in the way. They sort of pop, right? On the other hand, if we let it go, if we don't get in the way and I shoot it up high, look how long it lasts. It just keeps going and going and going. What else do you know that is sort of round in shape? And if you touch it, it'll pop, but if you let it go, it'll last for a long time.
Bubble.
bubbles, right? So it might be that there's something special about these. They're sort of like bubbles. Now we've got one more demonstration for you guys, and we're going to talk a little bit about temperature. And we've got this stuff called liquid nitrogen. Now you guys might know nitrogen is mostly what the air is made out of. But to get it to form a liquid, you have to get it down to like minus 250 degrees C. Alright, so that is really, really, really cold. And it's so cold that it can freeze things instantly. Now let's watch. Chris is going to do a few cool things with it. Now, do you need me to hold anything?
I got it all.
All right.
So that last demonstration, you guys probably have a trash can at home, right? And again, when your parents aren't home, you can cut a hole in the bottom and make a...
And you can even see how cold it is. Frost is already forming on the outside.
This stuff you can't get at home. We get this at, there's a place that makes liquid nitrogen just south of downtown.
Like, okay. It won't hurt you, but...
So yeah, you can see it looks like water pouring out.
But suddenly it forms a gas and it's evaporating.
Whoa. It freezes thing instantly.
And you can see, those are all frozen. Yep.
Oh.
So now we're going to freeze some other things really quickly.
What do you think would happen if I freeze a banana?
It'll freeze.
Yeah. And this will let you know what happens if you stuck your finger in here. Because your banana is kind of soft like your finger, right? This is a real banana? Okay, let's stick it in there and let it freeze. And you can see it's boiling. If you look in there, don't stick your hand in there.
It's so cold, it's boiling.
Yeah, this stuff boils at, what did he say? Minus
250 some degrees C.
Yeah, maybe. Oh yeah.
Or they actually call it boiling.
It's about
I played with
300 degrees colder than ice. Now, this will take a while to freeze, but we can take a flower. James can take some flowers. We're gonna freeze some flowers.
As long as you get it off fast, it's not going to be a problem. But check this out. Now,
perfect. Now, let's see what happens when we have frozen flowers. James is gonna high five me
with the flower. And it shatters.
They shatter like glass. Do you hear that?
And I'm gonna take a picture.
Let's do another flower.
But all these flowers are making me hungry.
Well, let's do a flower and then we can eat something.
Oh, okay. I always have to wait for my snack time.
Let's freeze these.
Wow,
and they freeze super fast.
Why don't you put the theater gas
who wants to crunch some flowers with their hand? Who's brave enough?
Whoa!
Just crunch them. Yeah.
So
the flowers don't hold onto the cold for very long, so it's okay to touch those with your hand.
Can we check on the banana now?
Let's check on the banana. The banana, you don't want to touch it because it's gonna pull all the heat out of your hand, or it's gonna be really, really cold.
Now they're right.
But now, what can we do? Let's see if we can hammer it with it. Or we can, do you hear that?
Yeah, you don't really want your finger to do
banana
that.
sound like that?
Normal banana does not sound. Try to crunch it. Crunch it. What happens if you put the theater
Here,
gas
I'm gonna go.
Did I hear somebody say you don't really want to do that with
Do
your
you
finger?
feel how hard that is?
Ooh.
Is it cold too?
What's gonna happen with these? It's gonna pop. Nope. It's gonna squeeze and no air.
It's really, really cold. It's really solid. So we'll put that back in there.
So remember how we said the gas around us is mostly made of nitrogen, and that's liquid nitrogen. So we've got a gas in here.
This young man has a hypothesis, so maybe we can let him.
Once you put it in, air will.
Okay, so
let's see what happens when we stick a balloon in here.
Yep.
How are we doing on time? What time is it?
1:22.
Okay, good.
Excellent time.
Do you see it's
So all the air is turning into a liquid, and a liquid takes so much less space than an air that it looks like all the air is coming out of it. But the air is still in there. It's just really, really tiny now.
The end is still tied in the knot.
Now let's watch what happens when we take it back.
So this is like when you guys are on the playground, you're running around, and how much space do you take up on the playground? A lot of space, right? But when you get tired and you come back in the classroom, you can fit into a smaller space. And look at the balloon.
So watch what happens as that heats back up. So what happens to a gas when you heat it up?
I knew it!
It takes up more space, right?
If you blow on it, it helps. This is my favorite way to blow up a balloon.
I'm blowing up a balloon without even touching it.
Put the theater gas in there.
So now I'm getting a little hungry. I'm gonna make a snack. So I'm gonna eat some graham crackers.
No! Is that safe?
Yeah, let's try this.
Well, as long as he actually drips the liquid nitrogen off,
Yeah.
so that he's not actually eating liquid nitrogen,
And then-
it's okay to eat a cold graham cracker.
That is very cool.
That's the perfect solution. These have been in our box for years. They're totally stale. But after you dip it in liquid nitrogen, it's perfectly crunchy.
Now we have one last quick demo, but we need 2 volunteers that are about the same height.
Wait, one more demonstration to do. I'm kind of thirsty.
Oh yeah.
Want a cup?
Man, kind of freezing.
Wait. That cup is, it got all cracked up because...
Because we used it.
Actually, it does seem to be working.
Yeah, I'm just going to pour some in this cup.
Okay.
Oh, the banana's making a run for it.
Okay.
Oh, this cup is cracking. And I'm going to pour some liquid nitrogen into this beverage of mine.
Okay.
And then that's,
I smell wine.
And so I'm cooling down my drink here. And you see that I'm kind of thirsty, but it's not mixing. So I'm going to have to mix it a little bit. All right, so. Now you guys are all clean.
What's that?
It's soap water. I'm sorry about that.
What happens if you put the like cleaner gas in the nitrogen?
So it'll. Good question.
Yeah.
We'll have to try that some other time.
We have to move on because the music is going to start, but we're going to continue to do fun stuff over on the stage.
Yeah, so we're gonna be doing some stuff. It'll take us a little while to get set up, but we'll be doing some other experiments over there for you guys to try.
We're going to
Okay?
do more liquid nitrogen stuff, so yeah, stick around. We'll be over there.
But really.